students, welcome to Joint Chemistry. Now I am discussing about acid-base theory. In acid-base theory, there are different types of definition of acid and base like Arrhenius theory, Bronsted theory, etc. Now we are discussing about Arrhenius theory of acid and base. Arrhenius defined that acids are the hydrogen-containing compounds capable of giving protons through ionization in aqueous medium. So, for being an acid, according to Arrhenius theory, there should be two criteria. One compound must contain hydrogen and another one is the compounds are capable to giving rise protons to the ionization in aqueous medium. That is, Arrhenius theory is valid only for aqueous medium. And similarly, bases are which can produce OH minus through ionization in aqueous medium. And examples are Arrhenius HCl and H2SO4 are called Arrhenius acid because HCl contain an hydrogen atom and it is giving rise to proton in aqueous medium. And similarly for H2SO4, it dissociates into 2H plus and SO4 2 minus. So according to Arrhenius theory, HCl and H2SO4 are regarded as acid. Similarly for base, NaOH and NH4OH, they ionizes to OH minus and NaOH ionizes to OH minus, and similarly NH4OH ionizes to OH minus in aqueous medium. So NaOH and NH4OH are regarded as base according to Arrhenius theory. And another important notification is that neutralization is nothing but the combination of H plus and OH minus. In acid-base neutralization, heat of neutralization for an equivalent amount of any acid and base must be same, which is experimentally observed. This is experimentally observed phenomena. Limitation of Arrhenius theory. It is confined in aqueous medium. There are many acid-base reactions in non-aqueous medium that are not fall in Arrhenius compound. That is, Arrhenius theory is related to only for aqueous medium. For non-aqueous medium, it is not valid. And the second limitation is many non-hydroxylic compounds like NH3, Na2CO3 also capable of generating OH minus in aqueous medium, but they are not regarded as base in Arrhenius concept. And similarly, SO3CO2 having no hydrogen are known to generate H plus ion in aqueous medium but cannot be regarded as acids according to Arrhenius, like NH3 and N2CO3 that cannot be regarded as base according to Arrhenius theory because NH3 and Na2CO3 does not contain any OH minus ion, but they are capable of giving rise to OH minus in aqueous medium. And similarly for SO3 and CO2, they are not regarded as acids in the viewpoint of Arrhenius theory. Now, what is Lewis theory? According to Lewis theory, acids are defined as any species with vacant orbital. That is, according to Lewis theory, acids having any vacant d orbital or vacant p orbital that are regarded as acid in the viewpoint of Lewis theory, and bases are compounds with available pairs of electrons. Students, now we determine the strength of acidity in the viewpoint of organic compounds. The acidity of the organic compounds depends on resonance effect, inductive effect and hydrogen bonding effect, that is plus R or minus R and plus I minus I, etc. Let's an example. CH3COH is an acid and its conjugate base is CH3 C double bond O minus. Here the O minus goes to conjugation with the C double bond O, so this conjugate base becomes stabilized, and as the O minus going to the conjugation with the C double bond O, so this O minus cannot donate any electron pair, so it behaves as the weak base. And like when the conjugate base is weaker, and then the acid will be stronger. If the stability of the conjugate base increases, then negative charge will be stabilized and it cannot give electron pair that behaves as weak base. So when the conjugate base is weak, then the acid will be stronger. Now we are discussing about the problems regarding the inductive effect. And we know that the plus I effect increases the electron density of the atom, and minus I effect, which is called the withdrawing effect, decreases the electron density of the atom. The first problem is CH3COOH, and another acid is given NO2CH2C double bond OH. Their pKs are given, one is 4.76 and another one is 1.68. Now we determine the increasing order of the acidity. So this is the conjugate base of the first one, and this is the conjugate base of the second one. Here in case of the second, here the NO2 behaves as a minus, NO2 is the minus IF, behaves NO2 gives minus I effect, so it pulls the electron towards itself. So this marked carbon gets the electron deficient, and O goes to more and more conjugation with the C double bond O. So this conjugate base will be the stabilized mode, and its corresponding the acid gives the higher acidity. NO2 shows minus I effect, so the carbonyl carbon gets electron deficient, and O minus causes greater conjugation with the C double bond O. So the RHS, CB, that is this. So the RHS CB is stabilized, and acidity will be 2 greater than 1, and pK 1 greater than 2. And we know the relation about the with increasing the acidity pKa decreases. Acidity with increasing the acidity pK decreases. Now the second problem is FCH2 C double bond OH COOH and ClCH2 CO2H and BrCH2 CO2H. Now we are discussing about the increasing trend of the acidity. So we focus it on the electronegativity concept. So here electronegativity trend is F greater than Cl greater than Br. F is the more electronegative atom among the three. So F pulls the electron, so this F pulls the electron towards itself, and the C double bond O, this marked carbon gets more electron deficient, and O minus gets more and more goes to more and more conjugation with the C double bond O group. So this conjugate base will be more stabilized, and the acidic strength is 1 greater than 2 greater than 3. So with increasing the minus I effect of carbonyl carbon gets electron deficient, and O minus causes more and more conjugation with the C double bond O. So stability of the conjugate base increases on moving from 1 to 3, and the acidity also increases. So acidity trend is 1 greater than 2 and greater than 3. Now the next problem is here benzene ring, and here pK is given 4.20 and 3.45. And for it is the same for the previous example, like NO2 minus giving the minus I effect, and here benzene ring gets more the electron deficient due to the NO2. So increase in the electron deficiency of the carbonyl carbon, and the conjugate base will be the more stabilized. So for same, the acidic strength will be 2 greater than 1. So the next problem is, here three acids are given, CH2CH2COH and CH2 double bond CH2 CO2H and CH triple bond C bond CO2H. So this is the conjugate base of 1, and it's the conjugate base of 2, and it's the conjugate base of 3. Now here this carbon is sp carbon, and this carbon is sp2 carbon, and this carbon is sp3 carbon. Now we can we know that the percentage of S character is greater for 3, then 2, and then 1. For sp, the percentage of s character is greater than sp2 and then sp3. And we also know that with increasing the percentage of s character, electronegativity of the atom increases. So as here the percentage of s character for compound 3 is greater, so here this carbon is more and more electronegative. And for same with the previous example is that this carbon pulls the electron towards itself, and so the O minus goes to the more and more conjugation with the C double bond O carbon, C double bond O, C double bond O. So C double bond O, because this carbon gets electron deficient due to the greater electronegativity of this carbon. So in case of the 3, percentage of S is most, so sp carbon withdraws the electron towards itself, so carbonyl carbon gets electron deficient, and the conjugate base is more stabilized for that, 3, so that the acidity order is 3, greater than 2, and greater than 1. This is the acidity order. And the next example is, here 3 compounds are given and their pKs are also given, and it is seen that these 2 compounds have the similar pK and this pK is greater. So it is assumed that this compound has the lower acidity, as with increasing the pK acidity decreases. In the first and second conjugate base, this is the conjugate base is first and is the conjugate base is second and is the conjugate base is third one. First and second conjugate base is more or less same stable due to the presence of minus I effect of OMe group, but the third conjugate base is somewhat unstable, as here minus I effect of OMe group decreases. So why the minus I effect of OMe group decreases in case of the third compound? Because minus I effect depends on the chain length. For this, minus I effect is greater. For ortho position, minus I effect is greater than this position and this position. Like for ortho position, as minus I depends on the chain length. Minus I effect depends on the chain length. So for this position, minus I effect is greater than this, and for this position the minus I effect is least. This position minus I effect is least. So for that case, according to the stability of the conjugate base, here we can say that the acidity order -1 equals to 2 and greater than 3. So guys, these are the problems by using the inductive effect. In the next video, I will upload some problems regarding resonance effect and hydrogen bonding effect. I hope it will be helpful for you, and for any queries regarding this video, you can mail me. So please do subscribe and share with your friends, and thank you.